Hello, welcome to Rules Battery Engineering's webinar series. Today we're going to talk about equalization of batteries. Just some real quick housekeeping issues. We try to keep these short. This one actually won't be too long. I'm figuring 20, 30 minutes the most. We'll have a short Q&A session at the end if we have questions. Everybody's microphones have been muted so we don't get any echoes. And if you have any questions, you could please type the text, the questions in the text field, and we'd be more than happy to help you out, answer the questions for you. If you don't have access to the chat pane or you are watching this on YouTube, you can do two things. First thing you can do is you can email me at steve@surrett.com, and I will be more than happy to reply back to you. Or if you are watching us on YouTube, then you can put a posting or a comment below. If you have any questions, comments, concerns, or suggestions, we'll be more than happy to take a look at them. Thank you very much. My contact information, my name is Steve Higgins. I'm the Technical Services Manager at Rolls Battery. My email address is steve@surrett.com. That's probably the best way to get a hold of me usually. Send me an email at steve@surrett.com with your phone number and a question. I'll be more than happy to give you a call back or send you a reply. I do spend a couple hundred days a year on the road traveling, so sometimes I'm in places where there are no, where the phone reception can be quite challenging at times, phone and internet. So that's one of the great things about the solar business. Okay, back to equalization. First and foremost, why would you want to equalize your batteries? Something to keep in mind is most of the systems that we're talking about are renewable energy or solar applications. When you charge and discharge a battery bank or cycle a battery bank, not all of the sulfate comes off the plates every single time you cycle it. And so what will happen is the sulfate, the SO4, will populate on the plate. It'll harden, crystallize and harden. And so it can become very difficult to remove if it's removable at all. This is very common when you're using the batteries in a partial state of charge or what we call a PCSOC operation. But first of all, it's important to make sure you understand what's going on within the battery. And so that's what I have these chemical equations up here for. Now we're going to talk about discharging first. Now discharging goes from left to right, and what I'm going to do is I'm going to mark up my screen here with the pen. We have a fully charged battery and we're going to discharge it. Okay, so what we're going to do is we have lead oxide plates and sulfuric or electrolyte, and as we're discharging, we're releasing electrons. Okay, on the negative plate we have a lead plate and electrolyte or sulfuric water and sulfuric acid mix. So as we are discharging, so basically we're taking the batteries from left to right, we're discharging both the positive and negative plates turned into PbSO4, basically lead sulfate. We have released our electrons, which is here, okay? We released our electrons, and so now the battery becomes discharged. The way a battery works is you have two unlike metals in basically a sulfuric acid mix. You're going to get a chemical or electrochemical discharge, okay? When you have two like metals, PbSO4, okay, and basically water, you get nothing. You get no electrons, so that becomes a discharged battery. Okay, so we go into, I'm going to erase the ink, and so we're going to go the other way. So we start with discharged batteries. Okay, discharged batteries and basically heavy water. So now what we do is we're going to push electrons into the negative plate by charging the batteries. So electrons are flowing into the battery. That's releasing hydrogen. Okay, and so now what we get is we get the lead sulfate negative plate changes into a lead plate in H2SO4. On the positive plate, we're pushing those electrons. So now the electrons are stored, and now we're we're charging the battery, so hydrogen is being released, okay? And now we get a PbSO4 plate that changes into PB lead oxide, and then now we have lead oxide in a vat with lead oxide plate in a vat of sulfuric acid. And so that's basically how in a real quick, dirty nutshell, how the batteries work. Okay. Now, we at Rolls probably answer, 10 to 20 phone calls, tech support a day. Sometimes it's heavier, sometimes it's lighter. Often we will talk to customers where they've got a battery bank where they haven't been properly charging the batteries, or something happened, the batteries became sulfated. A lot of customers don't understand this is a natural occurrence within a battery. If I take a brand new battery, I put it on the charger, the second I take that battery off the charger, it starts to sulfate, which means there's a chemical reaction within that battery where the SO4 starts to populate on the both the positive and negative plates. This is natural. It's not a big deal. What becomes a big deal is when that sulfation spends 3, 4, 5, 6, 8 weeks on the plates and it hardens, much like plaque on your teeth. If you don't brush your teeth, the teeth are going to turn yellow. Well, what happens with batteries, if you don't charge your batteries, what happens is now the batteries start to become sulfated. So when I'm circling some of these plates, this white stuff that's on these plates, these are batteries that have been brought back under warranty because they were failed because of defective workmanship. When you can look at these batteries and go, well, geez, look at the sulfation on the plates. That's hardened sulfation. You're going to lose capacity for that. Matter of fact, this battery right here, this damage right here is caused by where you see you're actually losing active material. This customer has been equalizing so much that they're actually causing damage to the battery. And so this is where equalization is not good, because you eventually damage the battery. So the ultimate question is when do you equalize? Okay, equalization can be useful in certain circumstances. Ideally, if you were properly charging your batteries correctly, and your batteries are seeing a full charge from at least every 1 week to 4 weeks, you're never really going to have the need to equalize. Now that 1 to 4 week process or period is based on how hard you're working the batteries. The heavier you're cycling them, the heavier you're using them, the more often you're going to have to equalize, or get the batteries to a full state of charge. The lighter you're using them, the less often you need to get the batteries to a full state of charge. So if this is a full-time, full-use cabin where you're doing 25% cycles every single day, you need to get those batteries to a full state of charge about every 2 to 3 weeks. If you're doing a 30 to 50% discharge every single day, you need to get those batteries to a full specific gravity, 1265 to 1275 if they're Rolls batteries, to a full state at least once every 7 to 10 days. If this is an off-grid cabin where you're it's a weekender cabin where you're not using it very often and you're just floating the batteries most of the time, you still want to cycle them, but you don't have to get them to a full state of charge, but maybe once a month. And that's usually pretty easy, especially if you're not there from Monday to Thursday. You typically have 4 days of full sun without any kind of loads to charge the batteries. A few cases that you want to start an equalization. The first thing you do is you want to look at the specific gravities. If you see that your specific gravities are all over the place, I like specific gravities, 1225 to 1250 to 1260 to 1210. The specific gravities are literally all over the map. That is why battery manufacturers refer to it as equalization. What you're doing is you're doing a controlled overcharge to bring those specific gravities to an equal state. That's when you want to do it. That's when you're looking at doing it. Another reason is that we'll talk about this a little bit later, but when you try to adjust or correct low specific gravities, a lot of installers or owners will start to equalize, or they'll do equalization charges to cover up the fact that they've been undercharging in the first place. Batteries are going to react better, lead-based batteries are going to react to a higher voltage or a lower voltage longer charge than a higher voltage shorter charge. Okay, so typically what I'll do first is when I see a battery bank that's got wide varying specific gravity ranges, or all the specific gravities are low, I'm going to adjust the charging parameters up a little bit for 2, 3, 4 weeks before I start to do equalization charges. And then the third reason why you would want, when you want to start an equalization charges, is when you have perpetual charging difficulties due to small charging sources. You know, customer's got a 1,000 amp hour battery bank with a solar panel array that's only capable of handling 20, 30 amps to charge. You get instances where solar panels have been covered up, things like that, where you have perpetual charging difficulties, and you have to do equalization charges to try to make up for that loss of power or that loss of charging, to try to keep the batteries in good health. All of these vary. It depends on the product you installed. One of the things to be very careful of is equalization should never be an automatic function. There are some charge controllers and some inverters that will do automatic equalization. I would be very cautious about those. And the reason for that is there's just too many things that can go wrong during equalization charge. With all that gassing, if you run the water, if you run the electrolyte levels low, if there's a loose connection, a spark, ignites the hydrogen. There's so many things that can go wrong during equalization. It's very important to be careful about what you're doing. Take it slow and easy, and definitely follow what the recommendations in our manual about when to do an equalization and how to do an equalization. How? Short list. We have a better description of this. I didn't want to cover every single one of them in this, but we have a manual that goes over this. It's a great manual. You should take a look at it. The first thing you want to do is check your specific gravities, determine if equalization is necessary. You take a look at it. Your specific gravities are all over the place. The first thing that I try to do is I try to run a little bit higher absorption voltage, a little bit longer absorption time for a couple of weeks prior to actually equalizing. If that fails to recover the specific gravities, then what you do is you start the equalization at your 2.58 to 2.65 volts per cell. The first thing you want to do is you want to check your water. If you check your water and it's right above the plates, add a little bit of water to it. That's not going to hurt it. But don't top it off all the way. If you top it off all the way to the bottom of the fill tube, with that extra charging, you might see the electrolytes spit out of the fill tube. If you're using a water miser cap or a standard bayonet plug, you don't have to take the bayonet plug off. Leave it on. Leave the water miser cap on. The only caps that you need to pull off are hydro caps. And the reason for that is that hydro caps have a palladium plate inside that gets really hot during the process of recombination. And that, coupled with the heat of the battery and the heat of the air, especially if you're in the summertime, can melt the hydro cap to the top of the battery. It's not nice. Start your equalization. Check the water levels of all the cells. Check the specific gravities of the cells. When the specific gravities stop rising for at least a 45 to 60 minute time frame, you'll want to shut the equalization off at that point. If you go more than 4 or 5 hours, you probably want to shut it off at that point and then give it some rest and start it again in 2 or 3 weeks. Don't do back-to-back equalizations. That's just beating the living daylights out of the battery, regardless of the manufacturer. That's like going to the gym. I skipped the gym on Wednesday and deciding to go double the time on Thursday. All it is it gives you, if you're going to do that with your body, it's going to open you up for more chance of injury. It's going to open the batteries up for more chance of failure or injury to the batteries. Once you've shut the equalization off, check your water levels again, check your hydrometers, top your water levels off at that point to where they're supposed to be. That way you don't have to worry about it for a few weeks. Once you topped off the water, do a full recording of the specific gravity, see where they're at. Wait 2-3 weeks. Again, maintain the higher charging set points. Wait a couple weeks. If the specific gravities haven't recovered, then try again. Okay. If after 3 or 4 attempts, 3, 4, 5, 6 attempts, and it still hasn't fixed the issue, it's a possibility that the sulfation was on the plates too long and they may not be recoverable. So you may be stuck with the capacity loss. Sulfation is not a manufacturing defect. Sulfation is a defect of the way the system was designed or the way the system was operated. Sulfation or batteries that need to be continually equalized generally is not a warranty failure of any manufacturers. It's typically a user failure, or there's even installer issues that come up with, under design, stuff like that. So be careful with that. Again, I've got to get off my soapbox eventually, but properly charging your batteries in the first place will prevent you from having to do equalizations. If you put in a system where you have a 800 amp hour battery bank and you've got 80 to 120 amps of available charge rate, and you're bulk charging at the correct bulk voltage, your absorption charging at the correct absorption voltage for the correct absorption time, you shouldn't have to do an equalization more than 1 or 2 times a year, if ever. So properly charging your batteries, properly doing your maintenance on your batteries is going to save you from having to do this extra maintenance to your battery bank. And it's going to save you from battery failures, and it's going to make your batteries last longer. So I want to thank everybody for listening. If anybody has any questions, I don't see any questions. If you do have questions, feel free to send me an email at steve@surratt.com. I'll be more than happy to answer any questions you have. If you want to give me a call, you can. The other thing that you can do is, since this is going to be on YouTube, feel free to click on the link below and post questions, comments, concerns, anything you want. Just keep it reasonable, and we'll be more than happy to take care of your questions. Thank you very much for watching, and hopefully we'll have a few more of these soon.